Okay, this is just a very quick video to basically try and convert you all to my side of an argument in trigonometry. That side being the discussion of what is better to use when solving trig equations. The graphs or the fancy, convenient, easy cast diagram. Now, in all my years of teaching students and classes, they all seem to prefer the cast diagram, and yet they all seem to make the same common mistakes, which is why I've always preached we should always be at least, as a first point of call, using the graphs, or at the very least using them to check out answers. Now, there's a couple of reasons for this. First of all, and this is more if you're starting from 0 on both of them, I think the graphs are just a lot easier. Just a lot easier to draw, a lot easier to memorize, a lot easier to work with. With the cast diagram, first of all, yeah, it's probably fine to remember, which quadrant everything goes into. But then you have to remember, if we're drawing, you've got to remember where am I finding my angles? What direction am I finding my angles? Which one's negative? Which one's positive? How many am I trying to do? All of these issues, and these are all such common issues that I come across, are solved by just using the graphs. Now, let me show you what I mean by that. Let's say we wanted to deal with a cos x between 0 and 360. 90, 270, 360. 90, I'll draw it on here, even though that's not completely correct, but just to prove my point. 90, 80, 270, and 360. If I wanted to find all of the values of cos of 70 between these, using a graph makes things so much simpler. All I need to do is have a look visually on my graph. Where is 70? Well, it is 20 to the left of 90. And using symmetry, I know this part here and this part here are the same, even though my awful drawing they are nowhere near. And I know that 20 to the left of 90, that section there, is the same as 20 to the right of 270. So cos of 70 and cos of 290 are the same thing. And to me, this is just a much easier visual way of being able to determine all of my values. Now, some of you may be thinking, well, if the cast diagram's too convoluted to learn and remember and use, then how am I meant to remember all the graphs? Well, first of all, if you're working with a calculator, if it's in a calculator exam or you just have a calculator around, it's a lot simpler to draw these graphs. All three of them, sine, cos, and tan, rely on not principal values, but rely on key values, which are every 90 degrees. 0, 90, 180, 270, 360, and continuing if you'd like to. Same the other way. If you have a calculator, you can simply pop each of these numbers into a cos, a sine, or a tan, get the values, and easily sketch the graph that way. Cos of 0 is 1. I'm starting up here. Cos of 90 is 0. So I'm going here. Cos of 180 is -1, and so on. If I just remember to do every 90, I can easily get the graph, because at this point we should at least know the shape of the graphs, including the tan. Now, if you're not using a calculator, I'd still argue remembering these are much simpler. Not only are they much simpler, but it's also almost mandatory to be able to remember these, because regardless of whether you use the cast diagram or not, remembering what these are is very useful. The second reason, and in some ways the most important one, because this is the mistake that gets done so often, is being able to tell immediately how many answers I'm expecting. The sheer amount of times that myself, when I was a student, my students, people that, colleagues of mine that do maths, answer one of these questions using a cast diagram, knowing the process, knowing the whole way, and they put too many answers or too few answers. There should be 3, they're putting 5. There should be 7, they're putting 6. Because with a cast diagram, it's not always intuitive to know how many answers you're supposed to have. Let's take this extreme example here. Let's say I want to find all of the equivalent values of sine 30 between 0 and 720. Now on a cast diagram, it's very easy to make a mistake here. But on a graph, as long as I've got the graph sketched out, again, it doesn't have to be neat, as long as you remember every 90. I haven't labeled the every 90 on here, but it's all the minima and maxima. As long as I get that sketched out, I can immediately tell how many sine 30 values am I going to have. Well, let's plot it on the graph first. 30 is here, roughly. Without even knowing the numbers, I can just draw a horizontal is a stretch, a squiggly horizontal line, doesn't even matter, could be wavy, maybe use a ruler. And I can immediately see how many times does it hit my graph, once, twice, 3, 4, and that's outside of 720. 4 times. There are 4 results. And then I can just use the symmetry that I saw earlier in order to be able to calculate the values. It should really just be as simple as that. And it's just easier to not make the mistakes when I'm using a cast diagram. Now, I'm not saying only learn the graphs. It's important as you learn mathematics that you know both, that you're comfortable with using the trig graphs and the cast diagram. But when it comes to exams, when it comes to a high pressure environment, you need the marks, or you just want to ensure the answer's correct, I would always default to this. But still make sure you know how to use the cast diagrams. I'll probably do a video at some point going through how to get the hang of them. But I implore all of you to at least, as a last resort in every question, consult the graph. Do a quick sketch, draw it on a graphing calculator, and at the very least, use it to check how many values you've got. Because in my opinion, it is much, much better.